Now, we had the corresponding angles postulate. The fewer postulates we have, the better. So we have these theorems that are coming up here, and we already talked about one of them in the last video. These are all things that can be proven by assuming that one corresponding angle's postulate. So with that in mind, they are not postulates. These are all theorems. They can be proven, which makes our case stronger. The fewer things you just assume are true, the better. The big thing here is alternate interior angles are congruent. So that would be like angle 1 and angle 3 in the image. They are congruent to each other. Consecutive interior angles are supplementary. So angle 4 and angle 3 have to add up to be 180. Up next, we have alternate exterior angles, and that's the one I mentioned before. That's like angle 8 and angle 6. Those two angles are always congruent to each other. So let's talk about a way to prove the alternate interior angles theorem, because if you look closely at the bottom of this little image, it says you will prove theorems 3.2 and 3.3 in exercises 30 and 35 respectively. So that's something that they do sometimes. Here's the theorem. We're not going to prove it, but you're going to have to prove it on your own later. It's something that you can do, but let's talk about how we would set that up. First thing we have to do is think about what we need. We need two parallel lines. All right, here's two parallel lines. They're cut by a transversal. All right, so I need to have two alternate interior angles. Let's make that angle 1 and angle 2. And I always like the alternate interior angles because it always reminds me of making a Z shape, which is kind of handy to kind of imagine that real quick. So we would want these two angles to somehow be proven that they are congruent. So that's our goal. Prove angle 1 is congruent to angle 2. The problem is we don't have anything yet. The only thing we have is corresponding angles. So I have to find a corresponding angle somehow. And it doesn't matter which corresponding angle I choose. I just need to find one and then make a new number for it. So let's take angle 2 here. What position is going to be corresponding to angle 2? Well, it's on the top right of the bottom intersection. So let's make another angle at the top right. We'll call that angle 3. So now angle 2 and angle 3 are corresponding. All right? So given, and this is what I call a poof. I'm not doing full list of all the statements and reasons in a T-chart or anything like that. I'm just kind of listing out what I would do. Angle 1 and angle 2 are alternate interior angles. Then I have to set up that angle 2 and angle 3 are corresponding angles, and that tells me that angle 2 is congruent to angle 3. So if there was only some way that I could show that angle 1 and angle 3 are congruent, well, angle 1 and angle 3 are vertical angles, which tells me angle 1 is congruent to angle 3. And guess what? I have two different angles. Angle 1 and angle 2 are congruent to the same angle, angle 3. So I'm going to use the transitive property. One thing I'd have to do is I'd have to switch the order here. Angle 3 is congruent to angle 1. And all of that leads me to transitive property. Angle 3 is congruent to, angle 2 is congruent to angle 1, and that's the transitive property. Last little thing, I'd have to just switch the order of those two things, and that's the symmetric property. Okay, So that's kind of like the outline of how I would write that proof. Now, if you were to actually prove this thing, you would have to write it out in a 2-column proof or write a nice paragraph proof for it. But basically, thinking about all this stuff here, it's kind of like a flow chart what I just made. I've got this thing that's given. I have to assume that. Then I move down here and go, oh, I need a corresponding angle, and I know those are congruent. And then I move down, and you can see I just keep following my logic down, and what I'm doing is making an outline for my proof, just like I would make an outline for writing an essay. Here's my idea. Here's some of my supporting arguments. Here's some evidence for each one of those arguments, like transitive property, symmetric property. And then when I get all down, I've got the conclusion. So this is basically just writing the outline for the proof, like you were writing an outline for an essay. What am I at my videos here? Okay. So now let's use those theorems. Reading Lane and Creek Road are parallel streets that intersect Park. So what that first sentence describes to me is this image here on the right. I'm going to draw a simpler version of that. I have Creek Road, Reading Lane. So let's call this line C, line R. And they're intersecting Park Road. We'll call that line P. And they tell us that they are parallel streets. So I'm going to write down that those two lines are parallel to each other. And I don't know if I did it before, but I'll do it in red so it really stands out. Those two extra arrows on those two lines say that they're parallel. And one thing I can do now is just put in all the corresponding angles so that I got stuff to refer to, same way that the picture looks. So I've just drawn a simplified version of what that map looks like. The road along the west side of Wendell Park. Yeah. So basically, the Wendell Park is the interior side between the two roads. That's extra information that we don't even need. If angle 1 equals 118, what's the measure of angle 2? So we have to think about how to get there. 118 degrees. Now, if there's a relationship directly between angle 1 and angle 2, we can use that theorem. And these are on alternate sides of the transversal, and they're both on the interior. So I would know that alternate interior angles are congruent, which is going to tell me angle 1 is congruent to angle 2. So angle 2 has the same measure as angle 1. It's 118 degrees. All right. You got to remember to read the questions closely. Sometimes you're going to be looking for a variable when they give you stuff written out in an expression. Sometimes it's the whole angle. Sometimes you got to find both of those things. So just pay attention to what the question really wants as its solution.